Which of the following complex numbers is equivalent to the quotient of 4 plus 7i and 12 minus 4i? Welcome back, everybody. Answer here is A. Let's go ahead and really show how this works. So to get this problem done, I'm going to first write off the problem again. 4 plus 7i divided by 12 minus 4i. And here's what we want to notice. Notice how we go from a complex fraction to really, if you look at the denominators, to a numerical denominator, not a complex denominator. So a real denominator. And the way that we're going to get that is by essentially getting rid of that I in the bottom. But the question is, how do we do that? And so the way that we're going to do this is by doing what's called multiplying by the conjugate of the denominator. Keyword being the conjugate. All right? So that's the word I'm using there. So if you need help with this, look that up. Complex conjugates. So I'm going to use the conjugate of my complex denominator. And again, what's a conjugate? Well, it's literally the same exact term or the same exact binomial, but I'm just going to change the sign. So instead of minus, plus. And I'm going to do that in my numerator and denominator because, again, if you're going to do something to the denominator, you have to do it to the numerator. Now, why does that help out? Well, here's what this creates. We have the same binomial except the signs are different. This is going to create a difference of squares. And if you don't believe me, no worries. Go ahead and follow along here. I'm going to work on the denominator first. So let me just write my fraction out. I'm going to only concern myself with the denominator. This is going to create, again, a difference of squares. Watch, I'm going to FOIL. So the first terms, 12 and 12, that's 12 squared. The outside, 12 times 4i. The inside, negative 4i times 12. And then last, 4i and 4i, so it's going to be negative 4i all squared. So notice how the middle terms are the same. One's positive, one's negative. Those will be eliminated. And so you're going to be left with, again, like I said, a difference of squares. 12 squared, 144, minus 4i squared. And so remember, when we do that, we're going to have minus 16i squared. Remember that I squared, we need to know this fact here. I squared is the same as negative 1. So if I'm going to go ahead and just draw this to the right here now, this is going to be 144 minus negative 16, which will in turn become plus 16. And then we can actually just erase this all together and write it out as 160. Because 144 plus 16 is 160. Now let's worry about the numerator now. Let me just erase these arrow marks that I made. Let's worry about the numerator. So in the numerator, we're going to do the same thing, and we're just going to go ahead and FOIL it out. First, outside, inside, last. So for 4 times 12, 4 times 4i, 7i times 12, and then 7i times 4i. And there we go. So far so good. Just make sure that you multiply every term from one binomial with every term from the other. You may know it as FOILing, but either way, all we're doing is distributing. So from here, well, I know that we have a common term within 16i and 84i. That's going to make 100i. Now, here's the thing. Remember, I squared, that is negative 1. So this turns into negative 28 because it's 28 times negative 1. So what's 48 minus 28? Well, that's going to be 20. So we have 20 plus 100i in our numerator. And so from here, well, now we can simplify because, again, we have that 160 there, and I'm going to erase it just so I can see it a little better. And what I notice is that, well, I can simplify all three of my terms here because they're all divisible by 2. Let me just use an eraser here to get rid of that 160 because I'm going to write there in a second. But notice how these are all divisible by 2. In fact, actually, these are all divisible by 4. I'm going to divide all of these by 4. So by 4, you get 5. By 4, you get 25i. By 4, you get 40. So really we have 5 plus 25i over 40. And I noticed again that we can again simplify even further by dividing all terms by 5. So we have 1 plus 5i, and that's an 8. So really what we have now is 1 plus 5i all divided by 8. And if we wanted to split these fractions up, answer A is exactly what we'll get, because you can rewrite it as 1/8 plus 5i over 8, which is exactly what's happening with A. So with that said, again, guys, these problems, we really are just trying to rewrite the complex expression by multiplying by the denominator's conjugate. Again, a conjugate is just the same terms, just a different sign in the middle. So if it was negative, positive. If it was positive, go negative. And there you are. We'll see you in the next problem.